Start, sir.
Okay. Welcome to this video lecture series of my processor and controller. I am Dr. Ivan Danakmar Joseph from Department of Computer Science and Engineering, here to explain the concept of 8086 microprocessor assembly language programming. So in this lecture series we are going to discuss about how we can write the program in 8086. So before that we are going to discuss or recollect the concepts of addressing modes in 8086, and then we are going to discuss briefly about instruction sets in 8086 microprocessor, and then we are going to talk about how we can write the programs in 8086 for various applications. Okay, so this is what the outline of this particular video lecture. So first we are going to recollect the concepts what we have learned in addressing modes in 8086 microprocessor. So there are variety of addressing modes starting from register addressing mode, immediate addressing mode, direct addressing mode, register indirect addressing mode, based addressing mode, indexed addressing mode, based index addressing mode, string addressing mode, direct IO port addressing mode. These are all various kinds of addressing modes used in 8086 microprocessor. So these are all one of the important concepts we very well discussed in the previous lecture video. Okay, anyhow, so before we are going to write the program, it is very important to understand what are all the addressing modes and what are all the various instruction sets available, so that we can able to write very optimized way of coding in 8086 microprocessor, that is assembly language programming. So 1 minute. Okay, so let us quickly recollect what we have discussed in the addressing modes. As I already explained, so these addressing modes are categorized into 5 basic groups. Okay, so these addressing modes are categorized into 5 basic groups. So first group, it talks about addressing modes for register and immediate data, and second group, it talks about addressing modes for memory data, and third group, it talks about addressing modes for input output port. So whenever we are connecting microprocessor with external devices, we can use these type of addressing modes and instruction sets. And fourth group, it talks about the relative addressing modes, and the last one, it talks about the implied addressing mode. So first one, when we talk about the register addressing modes, okay, in this kind of addressing modes or in this type of addressing modes, okay, so registers will hold the datas. Okay, so this instruction we very well known, this is move instruction. So what it will do, it will move the data from source to destination. That means the source to destination it will move. Okay, so here the datas are available in the register. Okay, so we already know the general purpose register of 8086 microprocessor. Okay, so it is accumulator, base register, count register and data register. So whenever register holds the data, okay, so these kind of addressing modes we are calling it as register addressing mode. Okay, so one more concept I want to recollect here. Okay, so 1 minute. Okay, so this X, okay, so if you see AX, okay, BX, CX, DX, okay, so this implies we are going to use 16-bit data. Okay, so that is categorized into two 8-bit data. Okay, so higher order 8-bit and lower order 8-bit. So each case it comes like this. See here, see this particular block. Okay, so there are 4 general purpose register: accumulator, BX represents base register, CX represents count register, DX represents data register, and it can be utilized based on the programming. We can also utilize it as a 8-bit. So lower order 8-bit, higher order 8-bit. Okay, that can be represented as AH for higher order 8-bit. Okay, AL represents the lower order 8 bit. Okay, I hope you understood. Next one is immediate addressing mode. Okay, so in immediate addressing mode, okay, so we send the data directly or immediate to the particular concerned register. So these kind of addressing modes, we are calling it as immediate addressing modes. I hope you understand. Okay, so one more thing I want to remind here. Okay, so here the H represents the, we are using hexadecimal datas, okay, or hexadecimal numbers. Okay, and also, okay, suppose if you are giving 08H, okay, the processor will understand it is a data. Okay, in some cases we have to represent the address directly. So in that case we have to use the square bracket so that the processor will understand it is an address. Okay, so these are all some difference. It will be very useful while we are writing the program. Okay, I hope you understand. So next, now we are talking about the immediate addressing mode. Okay, so in immediate addressing mode, okay, so 8 bit or 16 bit data is directly given to that particular register. Okay, so next one is the direct addressing mode. Okay, so here if you see that example, you can able to understand. Okay, so here, so this represents the memory location. Okay, so here we are directly giving the address of that memory location. From there the processor can able to take the data. So these kind of addressing modes, we are calling it as direct addressing mode. Next one is register indirect addressing mode. So in that case, if you see here, okay, this register, base register holds the data. So when you gives the bracket, I already told, when you gives the bracket, it implies the address. Okay, now you are giving BX inside the bracket. So what it means? Okay, so now the processor will go to the address location of that particular base register. From there it will take the data. So these kind of addressing modes, we are calling it as register indirect addressing modes. Okay, so next kind of addressing mode is based addressing mode. Okay, so here if you see here, you can able to understand. So anyhow, all these concepts are clearly explained in the video lecture of addressing modes and instruction set. Now we are just recollecting the concepts, because so based on this we are going to write a program, assembly language program in 8086. Okay, this is the concept of based addressing mode. So here from the base register, what is the displacement? So there it will calculate the address, from where it will take the particular data. Okay, so these kind of addressing modes, we are calling it as based addressing mode. Next one is indexed addressing mode. So in indexed addressing mode, it will we will use source index or destination index along with the displacement. Okay, so it total calculated the particular address. So based on that, go to that particular memory location. Okay, so it will get the data and it will move to the CX register. So these kind of addressing modes, we are calling it as indexed addressing modes. Okay, so next addressing mode is based indexed addressing mode. Again, base register will be there, then source index or destination index, and along with the displacement. So these kind of addressing modes, we are calling it as based indexed addressing mode. Next one is string addressing mode. Okay, so here we can able to move a byte. Okay, so these kind of addressing modes are called as string addressing mode. The next one is direct or indirect IO port addressing. So whenever we are connecting microprocessor with the external devices, okay, so our processor with the external devices, so we have to use port addressing modes. Okay, through the port we used to connect, whether the port can act as input port or output port based on the programming. Okay, so such kind of addressing modes, we are calling it as direct IO port addressing. For example, so here they are using the opcode in. Okay, so the in command is used to get the input from the external device to the processor. Okay, similarly out instruction is also there. Okay, to give the output to the external device from the processor. Okay, so next one is relative addressing modes. So the example will jump on 0. So first you will check the 0 flag, whether it is active or not, or enable or not. So once it is enabled, so it will come to that particular condition. Okay, so these kind of addressing modes we are calling it as relative addressing mode. Last one is implied addressing modes, clear carry flag, okay, clear CLD, clear direction flag. So all these kinds of instructions will come under the implied addressing modes. Okay, so we have recollect the concepts of addressing modes in a very brief manner. So if you want to learn in a very detailed way, you can see the video, especially the video of addressing modes and instruction set, so that you will understand very clearly the concepts. Okay, so now we can move on to the instruction set. So I will quickly summarize this one. Okay, so all the addressing modes in 8086 microprocessor can be categorized into 5 groups. Okay, so group 1 specifically deal with registers and immediate data. Group 2 is exclusively for addressing modes for memory data. Okay, group 3 it deals with the input output ports. Group 4 it talks about the relative addressing mode. Group 5 it talks about the implied addressing modes. Okay, so now we can go back to our one. Okay, so addressing modes we have discussed the concepts. So next one is instruction sets. Okay, so that is also discussed in a very detailed way. Okay, so before we are entering into writing a program, basic program to understand. Okay, so there are several instruction sets are used in 8086 microprocessor. Okay, so first kind of instructions are data transfer instructions. For an example, so I have quoted two instructions, move and exchange. We already discussed in the addressing mode examples what move instruction will do, right? So it will move the data from source to destination. Okay, so similarly arithmetic instructions. So several set of instructions available under the category of arithmetic operations. So for an example we have quoted add, sub. Okay, similarly bit manipulation instruction. So shift arithmetic right, okay, shift right, okay, or shift arithmetic left. Okay, so it will do some bit operations. So in some cases we will use microprocessor for several logical applications. So in that case these kind of instructions play a very vital role. Next one is string instructions. Okay, repeat, okay, repeat if equal. Okay, so all these kind of instructions are also available for doing the programming. Next one is program execution transfer instructions. So here we can use the conditional jump instruction. So all these categories will come under these kind of instructions. Next one, processor control instructions. So clear carry flag, clear direction flag. Okay, so set carry flag, set direction flag. There are several instructions available, okay, which can able to control the processor or which can able to control certain tasks during that application. Okay, so these kind of instructions are comes under processor control instructions. Okay, next one is exclusively for iteration. Okay, so we will also discuss in our next upcoming video lecture series loop, loop if equal, okay, loop if not 0. So all these kind of instructions will come under iteration control instructions. The next one is specifically for interrupt instruction. There are several type 1, type 2, type 3 is available. So these kind of instructions will be specifically used in the interrupt mode. Okay, so these are all the various categories of instruction sets that will be used in 8086 for a programming. Okay, now we will move on to the program. Okay, so first we will see the logic, then we will go for some simulation so that you will understand better. Okay, so I am taking very basic programming. Okay, so the first sample programming we are going to discuss is the addition of two 16-bit numbers. Okay, so what is the logic here? We already know 8086 is a 16-bit microprocessor, so it will be able to process 16-bit data. Okay, we can also able to use 8-bit data as possible. Okay, 8085 is a 8-bit microprocessor. Okay, this is for your information. Okay, so now you very well known about addition, right? So I am taking two numbers. Okay, so 20. Okay, you will do addition. Okay, here it is a hexadecimal number. Okay, now how it will do the operation? Okay, so this will be written as 0000. Okay, that is first 0. Okay, so how 3 will be written? 1100. This will be considered as 3. Okay, so all together we are calling it as 30. Okay, since it is a hexadecimal number. So how many bits are available? 1, 2, 3, 4, 5, 6, 7, 8. Okay, similarly again these two. Okay, so it will come as 0000, 0000. Okay, so I hope you understood. Okay, how processor will do the operation. Okay, so as a human being we can simply say 30 plus 20 50, but how 8086 processor will do the operation? Okay, it will consider each number into a binary form. Okay, and also it considered this one, you people very well known, right? So 1 2 4 8, this format, 8421 format. Okay, or otherwise we can say 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3. Okay, 2 raised to the power 0 is 1, 2 power 1 is 2, 2 square is 4, 8. Suppose if I want to write 3, okay, so 2 plus 1 is 3, remaining all zeros. Okay, suppose if I want to write 4, okay, so 4 is available directly, I am clicking here, I am putting 1, so remaining all zeros. I hope you understand these basic concepts, right? Okay, now, okay, so 30 first written, the next one is 20, right? Okay, so what is the value of 20? Here, here, here. So likewise it will add. Okay, so then it will give the data. Okay, 0 0 1. Okay, so what about the value? 1 plus 1, what is the value? It is not a number addition. Number addition will say 1 plus 1 is 2, but when we talk about addition of binary digits, 1 plus 1 is 1 0. Okay, so 0 and 1 will go to the next one. Okay, so this one. Okay, so what is the value here? This 4 is 0. What about this one? Right here, 1 2 4 8. Now say what is the value? 4 is enabled and 1 is enabled. So add the ones, the answer is 5. Okay, so this is how 8086 processor will do the operations. Okay, for example, I have shared the logic of how 8086 processor will do the addition. Okay, now we will come back to our program. Okay, so 1 minute. Yeah, fine. Okay, so now I want to add two 16-bit numbers using 8086 microprocessor. Okay, so this is my expected program. Okay, so here what I have to do? So first I have to get first number, right? Second I have to get the second number. Then I have to add these two numbers. Okay, then the result I have to store in one memory location. So this is the logic, general logic. Okay, so first for getting the number, okay, so I am using the command move. Okay, so I have to move the first number to one particular register. Okay, so for basic programs I am using some basic general purpose registers. Okay, so here I am using accumulator. Okay, so we already know the general purpose register, right? Accumulator, base register, count register, data register, right? Okay, so first I am taking 30H to accumulator. Okay. Second, I have to get the second number. Okay. Second number I am getting in BX. Okay. 20H I am getting. Okay. So H we are representing because so it will consider the hexadecimal data, that is 8086 microprocessor will consider the data as a hexadecimal number. Okay, that's why we are representing H. Okay, now the first step is over. I have collected two datas. What is the next step? That is the logic. I have to add these two numbers. For that I am using the instruction add. Okay. Now where the data is available? First number is available in accumulator, second number is available in base register. So I am going to represent accumulator, my first data is available, base register, my second data is available. So now the processor will add the data from accumulator and base register. Okay. Now where the result will be available? Okay, addition is happened. Where the result is available, 30 plus 20 is 50. Where 50 is available, the 50 will be available in the accumulator. Okay, so this is how the microprocessor will work. Okay, now what I have to do? I have to store the result in some memory location so that I can utilize the data for some other future purpose. Okay, so from where I have to move it to the memory? Now the result is available in accumulator. Okay, now I have to move to some memory location. Okay, so why I am putting as a bracket? So this bracket represents, so I am using here as an address, it is not a data. Okay, processor will understand, once you put bracket, processor will understand that it is an address of the memory. Okay, it is not a data. Okay, so I am writing move. Now all my logic is over. Okay, so I have get two inputs, I have moved to some particular registers, then I have done my logic, that is addition, then after that I have stored in one memory location. So finally I am going to terminate my program, or I am going to stop my program or end my program. For that I am using the instruction halt, that is represented by HLT. Okay, so I hope you understand the logic, right? So very simple, we can able to write in a very easiest manner. Okay, suppose, okay, so yeah, so now we will see two more programs, then we will go for simulation. Okay, similarly if you see here, okay, so here I am using multiplication. So here the program is multiplication of two 16-bit numbers. Okay, so whenever you are doing multiplication, what is the first step? You have to get two numbers. Okay, so I am getting the two numbers from the user and I am placing it in, okay, accumulator and BX. Actually we have to use CX. Okay, that is the correct way. Okay, CX. Okay, so mul CX. So if you use mul CX, okay, what it will do? CX, what is CX? It is a count register. Okay, so why I am saying CX means BX also it will work, but CX is the correct representation. Why I am saying CX means count register. Okay, so AX I am moving 3, data 3. Okay, CX I am moving 2. Okay, normally if you use multiplication CX, what it will do? 3 into 2, that is 6. Okay, so here the logic is there, you very well known, this is a count register. Okay, so if you add the value, okay, that is available in the accumulator, 2 times we have given. Okay, so 2 times if you add, you will get the result. Okay, so that is the logic processor will follow. Okay, so anyhow we will all will be discussed in very detailed way. Okay, so that I am not going very depth here. Okay, but the correct syntax is mul CX. Okay, if you use BX also it will work, no issues. Okay, why you are using CX? This is the reason. Okay, so it is a count register. How many times it counts, it will be do the repeated addition. Okay, so here the first 2 steps are over. okay, then this is the logic. You have to give mul Cx so that it will multiply the value with the accumulator. So the result will be available in the accumulator. I am moving to the memory, okay, then I am stopping here. Okay, so I will explain one more concept here while doing the simulation. Okay, this is the multiplication concept. Then factorial of n numbers. Okay, so when we do factorial of n numbers, okay, suppose if you are using 3 factorial, how it will start? 1 into 2 into 3. Okay, so this is how factorial, it is 6. Likewise it will work. Okay, now I am taking the value. Okay, so which factorial you want to do? Okay, then I am going to use the accumulator. I am enabling it as 1, okay, because it has to start from 1. Okay, then I am doing mul Cx, multiplication Cx. So what it will do, for example, I am giving value 3 here. Okay, so I am giving value 3 here. Okay, so here L represents the loop address. Okay, so you be careful, L represents the loop address, note it carefully, L represents the loop address. Okay, so first, okay, accumulator value I have enabled as 1. Okay, now so loop, whenever you give the loop instruction, it will check the count register. Okay, so how many times the loop has to perform. Okay, so it will check the count register, based on that it will do the loop operation. So here I am giving the loop address. Okay, so this L will again point to the particular place. So it will do again multiplication Cx. Okay, again it will come, again it will do. How long it will do? So until the count register value becomes 0. Every time it will decrement. So until it becomes 0, it will do the loop operation. Okay, after that the final result will be available in accumulator, and then it will be move on to the particular memory location. So this is a very simple program for finding the factorial of n numbers. Okay, so once again I repeat, so the logic you very well known. Okay, suppose if you are using 4 factorial or something, so you have to start from 1, then you have to increment and you have to multiply until that particular value comes, 4 comes. You have to multiply all the values and you give the result. So this is how I am doing in microprocessor 8086. So I am getting the value in count register. I have set the accumulator as 1. Okay, then I am giving the instruction mul Cx and I am giving the loop. Okay, so this loop will do continuously until the Cx value becomes 0. Okay, once Cx value becomes 0, it will come out of the loop and it will come to the next line. Okay, so this is the concept. I am sure you already learned in the previous video. Okay, so previous video is exclusively for addressing modes and instruction sets. Okay, so kindly, if you are not having aware about instruction set, you kindly watch the previous videos so that you can understand better. Okay, so once the logic is over, I am moving the result that is available in the accumulator to the memory location, and then I am terminating my program or stopping my program, because my entire logic is completed. Okay, now we will see the simulation so that you will understand better. Okay, so this is the emulator I am using here for showing the simulation of the program 8086 programming. Okay, so here we will see one, because of the time constraint, we will see one program so that you will understand better. So I am using the emulator EMU 8086. Okay, so first I have to type origin address. Okay, 00H it starts from. Okay, then okay, so I am going to do the addition of two 8-bit 2 16-bit numbers. Okay, you will understand better. We already discussed the logic. Now we are going to see how it works. So what is the first step? I am going to get the values in accumulator. First value I am going to get accumulator directly. Okay, so 30 hex I am going to get in accumulator. Next value I am going to get in base register. 20H. Okay, now I am going to give the logic add AX comma BX. Okay, so now it will do the addition. Next one, I have to move the result to some memory location. Okay, I am giving us 3000H. Okay, so one more concept here. Okay, so I am not using the address from the starting itself because there are some pre-registered locations. Okay, we cannot use it. Okay, so that also you will come across in the while you learn the architecture of 8086 because that is already defined. All the programs are predefined in that particular location, so that you cannot use that particular location in the addressing modes. Okay, now okay, so I have written the logic. Now I have to click the emulate. Okay, so once I click the emulate, so original source code comes here, and also if you see here emulator screen is available. Okay, now if you see the left side registers. Okay, so accumulator value is 0, base register value is 0, count register value is 0, data register value is also 0. So this is the initial condition. Okay, now I am going to do single step compilation. Okay, so that you will understand better how things are happening. Okay, so I am click the single step button or icon. Now see here, what is the first line? So move AX comma 30. So the 30 hexadecimal value is moved to the accumulator. See the original source code, the compiler is moved to the second line. Okay, so first line compilation is over, there is no error, so it moves to the second line. Okay, see here, see the emulation screen, accumulator value. So the 30 is moved on to the lower order 8-bit because I have used only 8-bit instruction 30, right? So it is moved to the lower order 8-bit. Okay, so you very well able to notice here. So yeah, 1 minute. See here, you can able to see, right? Okay, so now the 30 is moved, right? Now again I am going to do the again I am going to do the next line compilation. See here, again the 20, see here 20 is moved to the base register. Okay, okay, so I hope you understood. So first two values it is moved. Now first two values it is moved. Okay, okay, now I am doing the next compilation. So the addition logic happened. Okay, add AX comma BX. So 30 plus 20 addition happened. So where is the result? The result is updated in the accumulator. Now if you see the accumulator value, it is updated as 50. Earlier it was 30. Now 30 plus 20 logic happened. Now the result is updated in the accumulator as 50. Okay, so what is the next step? I have to move the accumulator value into the memory location. Okay, now I am doing the next step. 1 minute. So now I am doing the next step compilation. Okay, now the 50 value data is moved to that particular memory location 3000. Okay, now we will see the memory location. So there is, if you see the bottom, okay, there are several icons or buttons available, right? Screen, source, reset, auxiliary. So I am clicking the auxiliary. So under the auxiliary, so I am clicking the memory. So if you see here, the memory, random access memory is open. Now I am giving the address. So my value is available in 3000. Okay, now if I am checking update, see here. So if you see here, so 50 is updated in the first row of 3000. Okay, so first, since it is a lower order 8-bit, it stores in the first stack in this particular memory rack. Okay, I hope you understood. This is the 3000. Then it will go step by step. Okay, I hope you understand the logic. Okay, how 8086 microprocessor works. Okay, Now we will see for multiplication. Okay, so we will quickly see for multiplication. Yeah, then we will go for okay, so multiplication, as I already told, okay, cx. So I also told why we are using count register. Okay, so I am just modifying the instruction mul. Okay, so here I am going to use cx. Okay, so for our basic understanding, I am using the simple logic 0 4 and 0 2. Okay, 0 2. Okay, 0 2 I am using. Okay, now I am doing the emulation. Okay, so the original source comes, this is the emulation screen. Okay, I am doing the single step. So 4 is moved to the accumulator on first compilation, first line compilation. I am doing the compilation again. 2 is moved to the count register. If you see here, it is not go to the BX register, it is move on to the count register. So after doing the compilation, okay, 4 into 2, it is 8. 8 is updated on the accumulator. 8 is result will be stored in the accumulator. Now again I am doing the next step. Okay, so it is move on to the 3000, that is the memory location. Okay, so it is move on to the 3000. Okay, so now we will check the memory status 3000. Okay, so just update here. See the first one, it is the value 8 is updated in the memory location. Okay, so this is how microprocessor 8086 will work for that particular cases. Okay, so last program we will see one more. Okay, so the division operation also we will go through it. Okay, so I am using the base register. Okay, so I am using the value, so div for division operation. Okay, div ax comma bx. Okay, so likewise it will work ax comma bx, or otherwise we can use div bx, it will work. Okay, div bx, it will work. Okay, so one more thing also I am taking, I will explain why. Okay, 3002h, so comma dx value. So initially I am taking, so that is not required, we will see. Okay, how it works. Okay, now I will emulate this particular program, we will see the division result. Okay, okay, so now this is the original code. Okay, so now I am compiling it. Okay, 4 2. Okay, so if you see the division result, 2 comes. Okay, so we very well know 4 divided by 2, the answer is 2. Okay, so that is fine. Okay, now I am going to just modify the program. I am going to give the value 5. Okay, so now I am emulating once again. Okay, so again 5 is move on to the accumulator. Similarly, as per the program, 2 is move on to the base register. Now I am doing the division. Okay, see here, this only you can see it why we are using data register. See here, the answer 2 is move on to the accumulator. Okay, the remainder 1 is move on to the data register. Okay, this is how we can differentiate the values. 4 divided by 2 also, answer is 2. 5 divided by 2 also, answer is 2. So where is the differentiation? The remainder. Okay, that remainder will be available in the data register. Okay, similarly we can see lot of programs in the upcoming video lectures. Okay, so thank you lot. Okay, so this video lecture we have discussed about how we can write the assembly language programming in 8086. Okay, thank you so much.